Welcome to Walkabout the Galaxy, the timely astronomy podcast where the science is universal, the opinions are personal, and the deadlines are relentless. We are Strange Charm and Top the Astroquarks, also known as Josh Caldwell,
Addie Dove,
and Jim Cooney.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. We are also on the infamous World Wide Web at www.walkaboutthegalaxy.com, where you can see how to order a Walkabout shirt and support STEM education at the same time. If you do order a shirt, please also send an email to WTG, that's for Walkabout the Galaxy, at ucf.edu. And you can also email us there with questions, praise, and compliments, but nothing else.
Yeah.
No.
Our stumpers today are occupational. You are certainly familiar with the classic third season original series Star Trek episode Requiem for Methuselah.
Intimately.
And the character Flint and his android ward, Reyna.
I have a good friend named Marina.
Classic episode in my mind. It had a lot of third season issues, third season original series, but it also had some of the awesome essence of what made Star Trek awesome. And, but anyway, the character was, spoiler alert, from 53 years ago. The lead character is essentially immortal or has been alive for thousands of years. Mm-hmm. So if you discovered that you were like Flint and that you weren't actually going to die.
Nice.
And maybe after 50 or 60 years of doing what you're doing now, you got like, you know what? Maybe I'll try something else for my next. You'd kind of have to pass yourself off as a normal person who lives a normal lifespan. So then you got to move.
Yeah.
You know, you're going to move to some other location, adopt a new identity, and say, okay, now I'm going to be X, something else for the next 50 or 60 years. What would you do?
I would open a brewery.
What is that?
It's my nobody steal this TM.
Because she might actually be immortal and you're going to do this in 30 years?
No, this is also my backup plan if this job doesn't work out.
It's kind of worked out, though, for you already.
I know.
It's kind of impossible for it to stop working out in some sense at this point.
Once you have tenure, you do whatever the hell you want. You can open the brewery anyway.
As of Sunday.
That's right. Yeah, your new contract.
A brewery is a brewery and a bakery in one.
Oh, okay.
That one makes good sense because you do enjoy beer and baked goods.
And you can do like spent grain baked goods, so you can use the grains that you brewed with sometimes. And you can just do not that.
Wow.
It's really good.
Interesting. So people have done that. So it's not.
People use spent grains for baked goods. There's a place in Austin I went to.
Spent grains.
That has baked goods and brewing. It's more of a. I don't know if they brew their own
What's
beer.
been removed from a spent grain that
it's been spent. It's been used for brewing. So
so something has come out of it, or it's
some
fed
of the
something
good,
or something.
Some of the good, if it's like barley and malt, some of the good extracts have come out.
Doesn't that end up making a deficient loaf of bread or something?
No.
When you're eating the bread, you're like, it just feels like it's kind of anemic.
No.
Okay.
I would give you. I'll find some good vegan spent grain bread for you, and
okay,
you'll be like, "Oh, this is delicious! I didn't even realize it was spent."
So you're going to be a brewery, a brewker. Mm-hmm. Oh, I like that. Mm-hmm. Yeah, BREWKER. Mm-hmm. All right, Addie Dove Brewker in her next lifetime. Jim, what about you?
I don't know. I spent a long time thinking about this.
Yes.
At first, I was hoping that I might get a different body and stuff, but then I guess I'm not. I guess I'm stuck with the same. So fashion model is out. But I guess I want to be a neurologist.
Oh.
A neurologist.
Yeah, that was another, that was...
I would do archaeology if I could.
Oh, that's another good one. Yeah, I just think, like, the human brain is so... phenomenally complicated and weird and odd, and I would love to understand more about how that works.
Yeah.
Okay.
I like it.
Yeah.
So you wouldn't be Would you be a clinical neurologist?
I think it would be like a
working with-
research neurologist,
Okay.
like a one of these MD, PhD kind of things, just doing research, trying to understand how the brain is doing what it's doing. I mean, for lots of reasons, just for interest. And I don't know, I'm currently, I don't know, it's frustrating how bad like mental health care these days is because we don't understand what the heck the brain is actually doing.
Right.
Yeah.
And so like, how does depression work or, clinical anxiety? And they're like, it'd be interesting
To solve those problems.
to solve those problems. And not just those problems, but just like, well, how does consciousness arrive and all this kind of fun stuff. So
Yeah. Okay. Mine is not that anybody's asking. But
Josh, what would yours be?
Mine is somewhat related to Jim's, although I would take a different approach.
Oh, yeah.
So mine would be sort of more in the AI realm, artificial intelligence, and I would solve all those problems you were mentioning by just eliminating people and replacing them with computers.
I see.
And
Trying to yeah.
So I'd be going for the sort of Matrix on the Matrix movies. I'm a little bit kind of leaning on the side of the Matrix.
Wow.
The Matrix. So he's evil.
Yeah. I'm a
The
little
Matrix
scared
were
right
bad
now.
guys.
Yeah.
I'm a little scared right now.
Well, I sort of I'm just kind of resonating a little bit with some of the things that the agents were saying in the Matrix about people sometimes.
People, man.
Sorry.
Yeah. No, I did. Like the bad guy in the Matrix there, or one of the bad guys that like he's eating that steak dinner. Somebody says, "I know this isn't real steak." Yeah, I get him. I get that. Like, it doesn't matter if it's real or whatever, right? As long as you think it's real.
Well, today we're not going to be talking any more about that stuff.
Okay, good.
We should have started with me and finished with the upbeat Brooker,
Brookery?
which is much nicer.
I have a name for it now, too. I can't tell you. I'm sorry.
Oh, it's
I'm actually going to save that
It's a
one.
trade secret. All right. Yeah, good.
I'll tell you after we stop recording.
Okay. Today we'll talk about Higgs bosons, plural. Red asteroids, also plural.
Whoa.
2 red asteroids, 2 Higgs bosons.
Nice.
And making stuff from light, in fact, from 2 photons.
Nice.
So
Pears.
it's all about pairs of things. And so we'll get to that. But speaking of making things from light, this episode of Walk About the Galaxy is brought to you by the electromagnetic field.
Oh.
A rolling, grassy field may look attractive, but after 30 minutes, you're sneezing with itchy eyes and trying to keep the ants off your feet. For true relaxation without the nuisance of sand, weeds, insects, and allergens, take a stroll in the electromagnetic field. While it whizzes by at the speed of light, you'll feel not the slightest breeze, but can bask in the warmth of its energy density. Choose the wavelength that best suits your needs, with options available from nanometers to kilometers. The electromagnetic field. I'm loving it.
Ba-da-ba-ba-ba. Are we allowed to do that?
Yes.
Okay. McDonald's.
Yep.
I was also singing like Strawberry Fields by the Beatles in my head when you were when you were talking,
Yes.
describing that. Fields forever.
So our friends at Virgin Galactic announced that they're
That
selling.
we'll never get to fly with them.
Right. They're selling tickets again. They sold tickets in the early days when they thought they would be up and flying operationally much sooner than they are.
Yeah, those people got a good deal, it turns out.
as it turns out.
As it turns out.
Well, how much did they pay?
$250.
$250.
Yep.
Times 1,000.
Times 1,000.
Oh, $250,000.
Yep.
Yes, and that was a bargain. Some of them, I think, it was only 200,000.
What?
And
Wow.
then they, at some point, they're like, "Oh, this is taking longer and costing more money than we anticipated." So they stopped selling reservations, but they've announced they're going to start reselling them at.
450.
450. But the people
Times
who bought
1,000.
it for 2 or 250
Probably still get
still have a
those,
seat,
yeah.
right?
Yeah.
They should.
Yeah, I don't know if they
fine
did it
print
like
of their
full payment or if
contracts.
they had a down payment, but they probably had a
did
contract.
deposits and contracts.
So, yeah.
Okay.
Yeah.
Yeah. And if you're a researcher and you want to fly with your payload, it's $600,000.
That surprised me.
And I think that does not include the full cost of a payload.
I don't think that includes anything except you.
Yep.
It's just the fact that since you're doing some research or something and it's a sponsored trip, it costs 33% more.
Yep.
I don't understand that.
I thought it would
really.
cost less.
I just don't understand it. But what do I understand? Not very much.
Not very much.
$600,000.
I don't understand much about economics.
So
I
what
guess.
that means
I
is
understand some things.
if you were writing a proposal, Addie, to NASA to do an experiment,
I would not get
you
funded.
would need to get $600,000 for you, and you needed to operate the experiment. You would have to have $600,000 for you to go on the plane on the rocket to operate the experiment. Plus, as you said, if your experiment is more than something that you can stick in your pocket, you would have to pay a payload space for that experiment as well.
Yep.
That's a really expensive experiment.
It
is
probably not going to happen anytime soon.
Yeah.
Unfortunately.
Yeah. We still don't know, do we, Blue Origin's prices?
Blue has not yet stated prices. They were apparently offering tickets to people who had made bids, those people who were high bidders
on their auction.
In the auction, but there's been no release as far as I know about what those were going for.
Yeah.
And both have said they're going to fly again, I think, before the end of the year.
Yeah.
At least once or twice, so...
So it'll be interesting to see how that whole market evolves.
Hopefully there'll be some non-person flights again before the end of the year too.
Right, with payloads.
With payloads like my payload.
For you and me. SpaceX has their Starliner. No, sorry.
Yeah.
Boeing has the
Starliner.
Starliner, which is to take astronauts to the International Space Station. It was supposed to launch earlier this week.
It was, and it first got delayed because the Nazca module, there's no S. I keep putting S in there. The new science module for the space station that the Russians built that was supposed to go up 15 years ago. So it launched and it docked with the space station. And at first it was like, yay, it docked. Well, at first actually it had issues as soon as it got on orbit and they had to sort some of those things out. But again, they built it it was supposed to be up 15 years ago.
Oh, so it's a little bit rusty.
Yeah, I don't know if they had finished it or just there was a few things left. Anyway, it's up there now. It docked. Everybody was like, yay. And then a couple hours later, its thrusters started firing and it spun the space station.
Oh, no.
It tilted it something like 45 degrees in one axis.
Wow.
And they had to then right it with the thrusters on one of the modules that's there. And so they did reorient it, but it was its attitude was wrong for a little while, which I always find a funny phrase.
Yeah. That had a bad attitude.
It had a bad attitude. Yeah. And that's kind of stresses that the space station wasn't really built to withstand because it was assembled in space.
Right.
So there's some pending investigations of how much damage that might have done. There was no obvious damage and no danger to the humans, and the solar panels all seem fine. But
yeah, it's not
scary.
It's not really a very maneuverable.
No.
It does.
They do boosts.
Now and again, they have to give it a little
But-
extra energy to keep it up there.
But it's not it's not a spaceship
No.
that's meant to go zipping around.
No, and quickly changing attitude.
Yeah.
And I haven't seen any video from on station at the time. I wonder if they have any.
Yeah.
Astronauts be like, what?
Spin is probably a little bit of when people hear spin, they think, I don't know, the teacups at Disney World or something like that.
True.
So,
But
so
anyway,
exciting.
so that delayed. So they
Starliner.
delayed the Starliner launch to just make sure everything was okay up there because it was supposed to go the next day, and then it was supposed to launch and didn't because there were some valves that read off what they weren't supposed to read.
There were also weather concerns at the same time on that for Friday. It's the time of year here in Florida where afternoon launches are problematic because of weather. So we'll see what comes with that. And then SpaceX's Starship, which is their stainless steel Flash Gordon upper stage rocket, has been perched. It was perched for an hour or so earlier today on top of their Starship. So we got on top of their Super Heavy.
Super Heavy.
So the Starship was put on top of the Super Heavy, and that doesn't have anything to do with the Starliner.
No.
And the Super Heavy.
You yelled at me
And
for
you
getting
have trouble
confused
keeping
about
these
that.
straight, Jim? Come on.
The Super Heavy is their booster, stainless steel, ridiculous booster rocket. Anyway, when those two were stacked together, 120 meters tall, 10 meters taller than the Saturn V.
Ooh.
So while it did not launch or not operational at that time, it was the tallest rocket ever.
Wow.
Yeah.
At that time.
And there were some pictures from earlier in the week when they were putting all the engines on that Super Heavy. There's 29 engines.
Raptor
engines, I think.
Yeah.
And it just looks it reminds me of when people play around in Kerbal, the program where you make spaceships and stuff.
Oh, I don't know that program.
And you just like shove things in there,
Yeah.
and it doesn't actually work, and then the thing explodes.
It looks like
It's like they just shoved a ton of boosters up in there, or engines up in there.
It's sort of like, or when you were a kid, you'd buy. You'd have bottle rockets, you know.
Yes.
You say, okay, I'm going to get like
Yes,
150 bottle rockets.
Yeah, when I was a kid, I did that.
and strap them together, right?
Not recently.
So that's the way that's kind of the impression that it gives with all those engines down there. So their orbital test flight would be the first time that Starship upper stage goes into orbit, but they're doing a soft ocean landing for
Starship?
Yes.
How does it land on a barge?
No.
Is it going to glide? Oh, they're going to lose it.
Yeah. They're ditching it. So they don't totally know
That
how
seems
either
like they're
the
trashing
Super
the ocean.
Heavy or the Starship are going to behave at orbital. The Starship first, the Super Heavy booster is this giant thing. It's its first launch ever.
Yeah.
And so they're ditching it in the Gulf of Mexico. And the
Can we start
upper
making
stage,
these companies pick up their rockets when
I
they're
know,
done with them?
It's a lot of litter.
Yeah.
It's just like people who smoke that are just
the
like
upper stage
throwing
is
their
going to
cigarettes out the
come
window.
back to near Hawaii, and I imagine that they're going to run it through here's how it will land, but they don't know the dynamics of everything and to be able to really plan getting it onto something. So they'll see how it behaves, but I imagine it will be coming in with its retro rockets firing to the surface of the ocean, at which point.
And they're going to launch that
will
from
sink.
Starbase, from the Boca Chica site, I think. They're not going to launch it from here
That's right.
in Florida.
It's launching from Texas. Yeah.
Aw.
Yep.
Yeah.
That would be a really good launch to see from here.
Yeah, 29
it's
Raptor engines
gonna be
ablaze.
yeah.
So that'll be fun. On Nerd News, I just wanted to mention the next Marvel Universe.
What if?
Shang-Chi and the Legend of the Ten Rings, which is obviously about Saturn's rings.
Yeah.
And
There's only 10?
Well, I'm curious to see how they define rings for
Yeah.
that and which ones they...
That makes sense.
Yeah.
They are kind of like glowy and blue sometimes in the depictions I've seen. So,
Saturn's rings
and the 10 rings.
and the 10 rings.
Yeah.
Okay.
There's also this What If that's coming online sometime soon. It's it's Marvel, right?
Yeah, that's like a cartoon Marvel Universe thing where they
Yeah.
what if things had gone differently in
Yeah,
various
so like
stages
different
of the Marvel Universe.
superheroes and stuff. It's a whole series of comics.
complicated.
It's
I
a whole
can't
series
keep
of
track
comics.
of
Some of them are super ridiculous and fun.
Yeah.
Yeah.
Well, let's talk about our first set.
Have you been watching the Olympics? Sorry.
Too much. Way.
That's only
That's
5
like all
rings.
I've been watching.
Oh.
There's 5 rings.
5 rings.
There's 5
Olympics.
rings in the Olympics, and there's also equestrian events, Jim.
Oh no. Are you trying to goad me to rant?
Yes.
Oh no, I don't know about this.
Yes.
Do you not like equestrian events?
I love equestrian events, but they're not in the Olympics. That's
They are.
rude.
I mean,
they are in the
skateboarding-
Olympics. They
skateboarding's
shouldn't.
in the Olympics
It's
now,
ludicrous.
too.
This isn't the horse Olympics. This is the people Olympics.
It's true.
The horses are the athletes in the equestrian event. I know that the people do some things, guide the horses or whatever.
Right.
But that's not an Olympic sport. Come on.
Do you think, how long has equestrian been in the Olympics?
Forever.
For a long
Like
time.
for a long time.
Yeah.
Yeah.
A lot of this stuff sort of dates back to the sort of late Victorian origins of the modern Olympics, I think.
Yeah.
So
I mean, I think
I like the spirit of like the original Olympics, right? Like
the ancient Greek Olympics.
yeah. So racing
human
and
achievement.
fighting, like equestrian event. Don't get me wrong, that's not a bash against equestrian events. It's fascinating to watch, and maybe if you like horses and stuff, it's
Yeah.
really cool. But
I learned
don't
this,
like it.
this time that there's trampoline is just by itself an event.
Oh, yeah.
And I feel like I've seen that before, but man, that looks dangerous.
loved it.
It was so crazy to watch.
Seems so fun to do.
It looks fun to watch.
Fun to watch.
but
Don't
my-
like. Yeah.
My rant
You
is
do your
about
rant.
anything where a human's subjective opinion is involved in
Oh, yeah.
determining who is the winner.
Agreed.
A lot of the events.
A lot of them. And
Yeah.
so while I like the gymnasts, I'm amazed at what they can do.
I think those are like superhuman achievements, and that should be in the Olympics.
They are, but it drives me nuts that the way they're judged is by somebody deciding whether your landing was bobbly or not.
Yeah.
It's like we can define, like have somebody with men's gymnasts, they have the rings, right?
Yeah. And they have to hold it
And
for
they
2
can-
seconds
they
or
can do a thing
whatever.
like that. It's like, well, let's give the gold medal to the person who can do this the longest.
Yeah.
Who can do the Iron Cross the longest. And they just like start the clock. There's no judgment involved. You're in it. You have a thing on
That's
it.
not
It tells when
gymnastics.
their arms go more than 5 degrees out of alignment. And that's it, right? And then that's amazing. I don't know if you've ever been on any of these gymnastic devices, apparatuses.
I did it when I was a kid. I did
one
all that
time
stuff.
I was in a gym where there was the pommel horse. And, when you see the ones who aren't winning the gold medals and they're spinning around on the pommel horse and their legs keep banging into it, it's like, what a loser, that guy. Then, one time I was up to a pommel horse. Guess what I could do?
You could get on it.
That's exactly right.
Yeah.
It took great effort.
Yeah.
But I did manage to heave myself up on top of it and then sort of lay there like...
Yeah. That is how I feel about the balance beam. Like, to me, that's the most impressive one that I see.
Yeah.
I couldn't even stand on that for more than like 10 seconds before I would just fall off. And they're flipping, and I mean, it's ludicrous.
Yeah.
Well, anyway, we'll have a special after hours Olympics episode of Walking Out the Galaxy at some point. But let's talk about our first set
science.
of astrophysical pairs with the Higgs bosons. It's the anticipatory giggle from top.
Usually when you say Higgs boson, it doesn't make Jim laugh.
There is nothing quite so funny as two Higgs bosons.
No, the reason I caught on to this article, there's nothing really interesting to say in this. I'll say, but it's all about Higgs boson self-coupling.
Oh my.
Self-coupling.
No, it's very appropriate. Bottom Cork is going out of town tonight, so
TMI.
Beauty Cork.
Beauty Cork, sorry. This actually involves beauty corks as well, interestingly.
Oh.
This is just a little update about the search for, so we found the Higgs
massive. The B quark is the massive quark.
It's a big one.
It should just be the big quark.
The big quark.
So of course that's
how I'm going to remember that.
I know.
The grand discovery that the LHC, the Large Hadron Collider, has made. I mean, it was kind of designed for and did find the Higgs boson. Right. This was a great grand achievement. But sometimes the Higgs boson comes in pairs. It self-couples and comes in pairs.
It comes in pairs?
Sometimes, if you're lucky.
That's
interesting. So
you are lucky. Anyway.
So what does that physically mean?
What does that mean?
That means it's in some sense like oxygen can exist as O, or it can exist as O2, where it kind of hangs out together. That's obviously on a very different scale. This is,
but how do you? There is something about the formation of the pair of Higgs bosons. I thought, so first, how do you make one Higgs boson?
So you make one or pairs by smashing together protons at ludicrous velocities. So this is what the LHC was designed to do. It takes a bunch of different things, but it takes, for example, protons and then speeds them up to nearly the speed of light and smashes them into each other. I mean, two beams going in opposite directions, smashes them into each other. That at huge energies, right? They're at ludicrous velocities.
So since they're moving very fast at relativistic speeds, their total energy, which is equivalent to mass,
is enormous.
Is much bigger than just a proton sitting on a table.
Right.
And pick up proton off the table, stick it on the scale, you barely notice it.
Right.
But when they're moving at 99 point whatever the speed of light,
they're thousands of times more massive than they would be otherwise, or effectively more massive than they would be otherwise, and thus out of that collision you can make things that
have more mass.
And the Higgs boson is one of those things, and a pair of Higgs bosons would be another of those things. Unfortunately, we discovered
so you need twice as much mass available in the collision to get two Higgs bosons out, and then you also need to be lucky that mass comes out in the form of two Higgs bosons.
Right, and that's the real rub, I think. The real rub is that it's something like 1,000 times less. The real rub.
Apparently he didn't do that on purpose.
I did not. I did.
Had to take our wayward glances to clue him in. All right, so tell us about the rub.
The rub is that it's something like 1,000 times harder to make a pair than it is to make an individual one, even if you have enough energy to make the pair.
Okay, but so what is the whole self-coupling, which I know is why we're talking about it? What does self-coupling mean? In the context, please,
Of the Higgs
Large
boson.
Hadron Collider.
I mean, maybe I don't. It's not. I don't know.
It's just the name they gave it.
It's just I mean, it's like an HH instead of an H. It's like a pair. You know. I mean,
so self-coupling isn't a process that gives. So when I saw that headline and the first glance of the article, I'm like, self-coupling is some sort of process where the two protons are coming together and they do something, or one proton does something that is a process that leads to the production of two Higgs bosons. You're saying, no, self-coupling is just the name attached to the production of two Higgs bosons, period.
Right. Except these two Higgs bosons aren't like just. It's not just producing one instead of two. They're two kind of bound together Higgs bosons. So it's like a pair hanging out
conjoined
together.
twins.
So they're coupled, but they're not really self-coupled.
Yeah.
They're coupled with each other.
Their own type. They're
whole,
type coupled.
Yeah, okay. Because, right. Okay.
I
They're just not coupled with a
what
different
you're saying.
type of boson.
But there are some, like a proton is, which kind of quarks are in a proton?
Ups and downs. Couple ups and a down.
Two of one and one of the other. You don't say that those two have self-coupled.
If it was just two ups hanging out together, I'd say
They're self-coupled.
Maybe you could say that.
Okay.
I understand
Well, in
what
any
you're saying.
event, I have a whole different view of what you're going to be doing this weekend now that I know what self-coupling
Apparently you're cloning yourself.
because it involves another Jim Cooney.
Yeah.
Hey, he's an attractive guy. I'm into it.
All right.
Works out.
But in any event, this article is basically just saying that we're looking for that at the LHC. There's an instrument on there called Atlas, which is searching for these kinds of things, and we're narrowing in on it. We haven't found those yet, so that's why this it's not like a super exciting. There's not a big thing to say, but we've kind of figured out what kinds of things this pair of Higgs bosons would decay into, and it would be a couple of bottom quarks. In most cases, it would be a couple of bottom quarks and a couple of tau leptons. And since you know what they decay into, you kind of look for that decay thing. Of course, those things immediately decay into other things as well. So what you're really looking for isn't even those four.
Right.
It's the byproducts of those things.
Yeah. R2D2 got very excited about that. He's joined us for the recording here, but he's off camera and not mic'd up for everybody listening.
Sorry, Art.
But so, yeah, and they did some super clever sort of data analysis thing to kind of push the limits of what kind of limits they can place on their detection. One of our next topic actually also involves sort of a self-coupling in a way of photons. But before we get to that, to give Jim a chance to calm down a little bit, I'm going to calm him way down. I'm going to really harsh his mellow with the trivia.
Oh, no.
So this trivia is in honor of the late Steven Weinberg, who one of the great physicists of our time, who was an acting physicist and professor at the University of Texas until the time of his death a couple of weeks ago. And he is most famous for the unification of what we call the electroweak force, the unification of electromagnetism with the weak nuclear force, two of the four sort of fundamental forces of nature in my simple-minded view of forces in nature in any event. So our trivia is all about Steve. And in fact, we have four famous Steves.
So not the atmospheric phenomena.
Who are no longer with us, not the atmospheric phenomena.
Okay.
The four Steves are Steven Weinberg, who we just mentioned, Stephen Hawking, Stephen Jay Gould, and Steve Irwin.
Oh.
Okay.
Okay.
Broad science spectrum there.
Your questions are, and let's just do them now.
Oh.
Okay.
All right.
Whoa.
Changing
I'm
it
not
up.
prepared.
Yeah. Which Steve wrote the book, The First 3 Minutes, A Modern View of the Origin of the Universe?
Weinberg.
Hawking?
It is Weinberg. R2D2 went for Steve Irwin on that one. What does he know? Which Steve does not have an asteroid named after him?
Irwin?
Yeah, I also think Irwin. It's shocking to me that the 3 others would.
Only one of those 4 does not have an asteroid.
Irwin.
Yeah, Steve Irwin.
You both say Steve Irwin. You are both incorrect.
Is it Gould?
No,
What?
it is Steven Weinberg. To
Wow.
what I could tell, I could not find an asteroid named after Steve Weinberg. It's possible. It's out there, and my research didn't uncover it. But Steve Irwin
Irwin have an asteroid.
asteroid 57567 Crikey. Named after Steve Irwin. Name submitted by
That's awesome.
the
I thought that you had to
Australian-
contribute in some way to
Typically you do.
Asteroid
Oh, there's
science.
all
There's
sorts
a few of,
we've
like,
done,
those special
we've done
ones, though.
asteroid name trivia before, and there's like James Bond asteroids and all sorts of things like that.
So I hold out
Stephen
hope
Jay
that there'll be
Gould
a
does,
Cooney.
and Stephen
Yeah.
Hawking does, and Steve Irwin definitely does. I could not find one named after Steve Weinberg.
we got that one wrong.
Which Steve is known for, quote, the chronology protection conjecture, which he personified in popular writings by a chronology protection agency, which psych totally Loki and the Temporal
Yeah, that's what I was
Variance
thinking.
Authority.
Yeah.
Yeah. The Chronology Protection Agency was a sort of representation of something called the chronology protection conjecture. Which Steve?
That's got to be Hawking.
Yeah.
It is Hawking. And
I hate guessing the same one, but
Yeah.
I don't want to get wrong again.
which Steve is known for the theory of punctuated equilibrium?
Gould.
Yeah,
That's
Stephen
Stephen Jay Gould, and it has to do with evolution going at
Gould in a
sort
long
of
time.
equilibrium, and then something
Yeah.
sort of
I remember learning that, and it
rapid
really rocked my world. I
variations.
thought that was really a
Yeah.
genius thing.
And your final one is which Steve's CV lists his Nobel Prize on page 9?
Weinberg.
Yeah, it's got to be Weinberg. He's the only one that got a
That is
Nobel
correct.
Prize. That group.
I was like, did Hawking get
I
a
was looking through his CV. Is very understated. There's no flowery
All his teaching
things
accomplishments
or
first.
boldface or anything like that. It's just sort of list of things. It has all sorts of things that he's done, and then on somewhere around page 8 or 9, it has awards that he wins. That goes on for a page or two. And Nobel Prize in physics. That's all it says.
amazing?
Yeah.
If I were
feel
that, I
like-
would have a 1-page CV, and that would be the only thing on it. Yeah, that's all you need.
Yeah.
Yeah.
Nobel laureate.
Okay.
I'm not sure I would keep a CV.
Yeah.
Who wouldn't hire Steve Weinberg if he were looking for a job at a physics department?
Sometimes you're just required to submit a CV.
Yeah.
That's
You know you're going to get it, but everybody's got to follow the rules. And if the
Yeah.
rule says submit a CV, you submit your
It
CV.
has to be more than one page.
And if you leave something out, maybe that's grounds for
Yeah.
not getting something. Okay, so our second pair of topics, our second topic of pairs. One of the cool things we were talking about, equivalency of energy and mass with the protons in the Large Hadron Collider, where they're moving fast. That energy of their motion is essentially equivalent to them being more massive. But literally, things can change form from mass into energy. And most famously, we talk about antimatter and matter combining and annihilating and producing energy in the form of photons.
Right? That's how they run the warp drive.
Yes.
Oh.
You
Amongst
just
many
need to
other
have
things.
dilithium crystals in there too. I'm not entirely
what
sure
they do.
what are the dilithium crystals doing. I don't know, right? Because you have the warp core or the antimatter in there, dilithium crystals.
Yeah.
Got to look into that. But in any event, Jim, you could also go the other way.
Yeah, I mean, it's just like throwing a ball up, right? You're transforming, not throwing it up,
Not a hairball?
not a hairball. You spend too much time with your cats.
I know. It was unpleasant.
But as the ball is going upwards, it's taking kinetic energy and transforming it into potential energy. You learn about this in Physics 1, and then as it's going back down, it's converting potential energy back into kinetic. So energy, as long as the total energy in a system is the same, then energy can swip around between
Any form.
any kind of form at
I
once.
love it when
and
energy swips.
swips.
It slips around.
And it's the same thing, yeah. With mass is just another kind of form of energy, and so you can
That's what Einstein told me.
transform, like we said, you can transform mass into the energy of photons, as Josh just said. Pair production. That's not called pair production. That's
No, it's not.
That's annihilation.
Pair annihilation.
Annihilation.
But in theory, you should also be able to go the other way. But
when a positron, which is an antimatter electron, collides with an electron, you produce two gamma ray photons, two very high energy photons. Right. I don't know, maybe some neutrinos pop out of that or something too. They're always randomly showing up places I don't expect them. It's like every time I go to get a different shirt out of the closet, there's some neutrinos.
Friggin' neutrinos, yeah.
In any event,
is that what causes those little holes in my shirt?
You primarily produce these two very energetic photons. Right. So then, in principle, what you're saying is if I could take those two photons, I could have them annihilate each other and produce a positron and an electron.
Right. Now, for reasons that I don't think I understand, and maybe you do, that reverse process is considerably more challenging to do. It's not a matter of having the right amount of energy, because of course it's there, but the kind of cross section, the interaction doesn't work as smoothly or as easily, or it's just not as easy to do. So even if you have like a bath of gamma ray photons flying around, almost never will they actually combine in just the right way in order to make the positron and the electron. But this is a really cool result that we found, and I guess I'm going to let you describe this because you were so geeked up about this also.
Okay.
Because it's really cool. They've found a really clever way of kind of faking it, not faking it, but
so they make it.
Yeah, I mean, when I first thought, okay, they created what you were describing as a bath of gamma rays, so just a lot of photons, high intensity, and they're coaxing them to interact somehow. And they sort of did that, but not really. And what they did was, the way that it was originally suggested it might be done back in the 20s or 30s.
Pre-laser.
Pre-laser,
yeah.
Right.
Where they said, okay, we'll take an ion and accelerate it to very close to the speed of light. And an ion moving thus produces perpendicular electric field and magnetic field, which is what a photon is traveling at the speed of light. So if this ion is traveling along at 99.99% the speed of light, it is basically the electromagnetic field that it's carrying with it is essentially a giant cloud of these photons.
Right.
So you almost collide two ions. So then you're sort of sending these two clouds of photons at each other. So they set up this glancing collision of these two ions. And in that glancing collision, for reasons that happen there that don't happen with a laser idea that we were saying that I don't understand why, those things do interact and produce the positron-electron pair.
Yeah, this is awesome. It's the first time this has been seen, right?
80 years or so.
Right, in laboratories. I mean,
because it's hard to actually do that experiment.
Yes.
Yeah, that's a really hard experiment to do. And like we said, I mean, I wish I understood this a little bit better, why we haven't been able to do it with just splashing lasers, gamma ray lasers or whatever together, but we haven't. And so this is the first time we've been able to see this reverse process that we predicted. And we're sure it happened. I think we've seen this astrophysically, but not, in a laboratory setting. So I think that's really cool. And that's a very clever way of doing it, but a clever way that, you're right, they figured out in the 1930s when they first were predicting that this kind of thing could happen, and lasers weren't around back then. So they were trying to dream up ways that you could make electromagnetic fields interact like that.
Right.
Yeah. They talk a little bit about how basically the lasers that we have the energy in the lasers isn't powerful enough yet for these interactions.
That makes sense, actually. That makes sense. Now that you say it. I mean, this thing is happening, by the way. This is they're doing these experiments at
SLAC.
This is not at the LHC, but this is at a
different accelerator.
The relativistic heavy ion collider, which is a cool sounding.
So they use gold ions, and because the ions are accelerating, they have this. Maybe I'm saying that wrong. But in any event, these ions are circulating around this accelerator. I cut you off.
No, you did. You're good.
And very close to the speed of light. So it's. I don't know, we think of you have a magnet, there's a magnetic field, and then light is oscillating electric and magnetic fields traveling at the speed of light.
Right.
Just the sort of idea that, okay, if I make an electric field, which I can do with some charges, and a magnetic field, you don't think that, okay, if those things were coupled in some way and traveling,
right?
Then you've sort of faked the creation of
it's pretty cool.
photons.
It's pretty awesome. Yeah. I mean, to be clear, this is really hard because, electric fields are all over the place. Magnetic fields are all over the place. But they have to be arranged in a very particular pattern. An electromagnetic wave, which is what a photon, what light is this oscillating electric and magnetic fields that are coupled together. So they're in the same. Their frequency is the same. And their amplitudes have to be in just the correct ratio.
Yep. So they have to have some pretty strong magnetic fields controlling some of this stuff.
Right. And that's the thing is that big, powerful electric fields are pretty easy to make with these ions. I mean, ions are very strongly charged, and they make these strong magnetic fields. Getting the powerful magnetic field to match the intensity or to get the correct intensity is not so easy. But if you accelerate these things to ludicrous speeds, then you can make those magnetic fields. And if you do it just right, the magnetic fields and the electric fields match, and then that just is a photon, right? By definition, which is kind of awesome.
Yeah, I thought that was fun and clever. Our final tale of Pears has to do with 2 red asteroids.
Are they red?
Yeah.
Really?
They would look black.
Reddish.
They would look black.
It would look jet black.
To the human eye, they would look like coal.
Yeah. But their spectra are red.
Yeah.
Are they?
It's not just a red slope. It's not just that it's red slope. It's that they are reddish spectra.
Explain.
What is that?
Talk to me.
Well, like a lot of times things are redder or bluer because of the the slope of their thing, and these I think do have more features in the reddish part of the slope. So I guess it is.
Slopey?
I guess it is
or
that
maybe
it's a slope.
Is there a red bump?
I didn't actually look at the full spectrum. Let me see what the spectrum looks like.
Anyway, what's the idea with these things?
They would look black.
They would look black.
So, for one thing, it's rare to find red asteroids. And that's because reddish things often are because they have things like organics and other materials that we just don't see as much in the asteroid
Carbon
belt.
molecules or so.
Carbons and sometimes like water even, you can get more reddish features, but we just don't see that as much in the asteroid belt because most of that stuff is pretty dry and doesn't have these molecules.
Right. Close into the sun, it's warmer. Those things don't hang around as much.
Yeah, so the asteroid belt, right?
The solar system is has a tendency to have sort of more reddish kind of colors, right?
Yeah, so these were 2 bodies that have been identified in the asteroid belt, which is, again, right between Mars and Jupiter. So inner solar system when it's pretty warm, where it's pretty warm. And it has been pretty warm for a long time. So it's pretty hard to explain how you get these things in this part of the solar system because everything else, all those molecules would have evaporated early on when these things were forming.
Yeah. Now, so these things are maybe interlopers or they came in from elsewhere?
So to jump to the end, they are probably they have similar spectra to some of the trans-Neptunian objects and centaurs. So it's likely that they were formed further out in the solar system and long time ago migrated in.
Okay.
And have some sort of a blanket of enough stuff that they've kept that those organic type materials.
Hasn't been weathered away or something. Okay.
I know you real grown-ups don't really make this distinction, but then aren't they kind of comets rather than asteroids?
No.
Oh, snap. Why not?
Because they are not on cometary orbits. They're they're in the asteroid belt, right? They have very sort of asteroid belty type orbits, relatively low eccentricities and stuff like that. And they aren't outgassing and stuff. So is your distinction between a comet and an asteroid? Are you going to have? I'm not in that battle. First of all,
you're not in that battle.
No.
Oh, well, I'm fighting you anyway because you're a representative.
You're the person in front of you.
Yeah, you're directly across from me.
So your problem is
my problem is
comets are icy and asteroids are dry.
That's right.
That's not the definition. That is
insane.
Useful these days.
I'll tell you why that's insane.
Because you teach.
Because I teach basic astronomy, and in basic astronomy, it's composition, right? Because to remind our viewers, listeners, etc., things that formed in the inner solar system formed mostly from rock and metal because those were the things that could condense out of the solar nebula in the warm temperatures in the inner solar system. In the outer solar system, Jupiter and beyond, both rock and metal and ices, things like water and ammonia and methane and stuff like that could condense as well. And so that's why you ended up with much larger planetesimals and much larger end planets in the end. And so usually when we're talking about, at least, like I said, in astronomy 101 sense, you're talking about the difference between asteroids and comets. Asteroids are made of rock and metal, and comets are made of mostly ice with some rock and metal.
What do you call TNOs, trans-Neptunian objects, and centaurs?
I don't know. What are those things? Where did they form?
Out there.
They're in the outer
Then I
solar
would call
system.
them comets.
Yeah, that's not really what they are, though.
So if those things...
There's like lots of different types of populations of objects.
Well, what are they made of?
They're made of rocks and ice and organics.
So lots of ice? If
Yeah.
they came really close to the sun, what would they do?
But they're not on orbits that will bring them close to the sun.
Then they're comets.
You have a very simplistic view.
Oh, yeah. I know.
Asteroids
I'm a simplistic dude.
Well,
No, there's this big debate between like wet asteroids and dry comets, and because like what if it used to be have all those organics and stuff and it outgassed all of them, but it's still on a comet orbit, but it looks like an asteroid.
Yeah, I don't know.
Is that an asteroid or a comet, Jim?
I don't know.
Yeah. I think, and I don't mean this to sound as harsh as it will sound,
Oh, it's going to be so harsh.
Ouch.
But I think-
Somebody's getting burned.
but I think that probably like our listeners, who cares, right, what you call it?
Well, I mean, we care.
I don't mean like our listeners are probably thinking right now.
Right. Why are you arguing about this?
this? Because those original nomenclature came from a time when we knew about many, many fewer objects than we now know about, in addition to knowing much, much less about how the whole solar system is set up and works and formed than we do now. So you saw a blue thing and a red thing, and you gave them two different names. And now,
Yeah, we need Beauty Cork on this episode to help us
Right.
get our nomenclature
So I don't
straight.
know,
I'm going to go home and rail on her about this. Yeah.
Minor planet, dwarf planet, moon, or whatever.
Yeah.
So these are two objects in the asteroid belt that don't look like
Don't
the
look
others.
like the others,
Yeah.
right? No, that makes
And
sense.
it looks like they came from the outer solar system,
That's interesting.
Yeah.
which is interesting.
That is interesting.
Yeah.
Yeah.
And one of them is especially interesting because so this is 203 Pompeia and 269 Justita. I don't know if I'm saying those
Neither one is 29605 Joshua Caldwell.
right. Neither of them is that.
Or-
They're much bigger than that because they have much smaller numbers.
Yeah, or 57567. Crikey.
Crikey. Or whatever mine is called.
27 something.
Addie
Addie
Dove. So these are they're pretty dark objects, and they looked at them in the visible and infrared, so they could get a sort of a wide range of wavelengths, and they're just much redder, so they have a lot more reflectance in the red part of the spectrum than a lot of the other asteroids, but it's similar to some TNOs and centaurs, but it's still really high. So Pompeia, I think, is actually a pretty big asteroid. So it's like 110. Did I just make up that number? I lost my number. It's a larger asteroid, which means it's probably never been like broken up and split apart. And so it's
We should get on that.
splitting it up.
Yeah.
Yeah. 110 kilometers in diameter, and Justita is about half as big.
Okay.
So it's probably never been broken up, which would have changed its orbit. So its orbit can't really do that. So it probably early on got sort of transported into the inner solar system. So it's been there for a long time, and we could send a mission there to study an outer solar system object.
for cheap.
Ooh.
Cheaper.
Right.
Yeah.
Which that is very cool. One of Saturn's moons, Phoebe, also is presumably something that came in from the further out even than Saturn, and that's based on these same sort of arguments about the spectral appearance of it. But one of the things that's interesting dynamically about this to me, and that sort of the orbital stuff, is the part that I'm more interested in than like the red part or whatever.
He would be.
But
He likes orbits.
it's easy to sort of scatter things in, like that's comets. We see comets because they get scattered into the inner solar system. They usually end up on what I was describing as cometary orbits, which don't look like these orbits. So if these things came in
and
then
then
they're
somehow
on these
got
sort of,
into
sort
the.
of ordinary asteroid belt orbits, that seems peculiar
Yeah.
to me, and a difficult dynamics problem to how you scatter them in through successive gravitational perturbations and other processes that change the orbits and then put it on a stable circular orbit in the main belt of the asteroid,
Right.
and not something that's sort of dynamically linked to Jupiter,
Right.
for example, like most short period comets orbits are.
So maybe the other possible explanation is it's some object that always was there and formed there, and then some other process
Maybe.
made it redder than.
Maybe.
Yeah. I mean, there's some hypotheses about how you could get these types of objects into these orbits because Ceres, one
That's
Ceres
a big sucker.
has some ices we now know, and some organics, and so there's some thoughts of like how that would have formed or maybe gotten there from somewhere else. So
yeah. Well, the solar system was definitely a dynamic place in the early days, and we're learning. The more we learn,
it's still a dynamic place, just a little bit.
But there was lots of shuffling around, and in ways that
lots of dance cards getting filled there.
Yeah.
That was a reference to something.
Maybe.
Yeah.
I don't know. But planets were swapping places, and the ice line was moving in and out, and all sorts. So anyway, then you would maybe expect more than two.
Well, there might be more, too. And a lot of these objects are really dark, right? So they're hard to see.
Hard to get these good observations. Okay. Well, while it may have felt like waiting for a pair of Higgs bosons to be created, it was just another episode of Walkabout the Galaxy. Give us 5 stars, and we'll give you 50 minutes of scintillating insights into the universe with a sprinkling of idiocy. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, where you can see most of our episodes, some of our bloopers, and all our music videos. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Production assistance provided by Diego Rodriguez. Thanks to our listeners in Tokyo and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the Astrofork signing off till the next episode of Walkabout the Galaxy.
Self-coupling.